So, formal verifications. What's the formal verifications? And where this formal verification exists in the life software development lifecycle. Actually, after analyze the software, after analyze the system, the real-time system, we will come out with specifications. We will come out with the requirements, and then we'll go for designing the system. So before design the system, before implement the system, it's better to design a model for this system. Design a model and then validate and verify this model. So here we are. We are in the designing stage. So we design a model for the system and then we check some properties. We check some properties like the safety of. So we check some properties like the safety, the reachability, the liveness. Some properties need to be checked. So before go for implementation, it's better to design a model. Design a model for the system. So by doing so, you save time and money. Save time because if you catch or capture the errors now, it will cost you less than you capture the error after implementation or after developing the system. So in the design, in the modeling design, here is the formal verifications. So what's the formal verification? Actually, as we say, formal verification, it's verify whether the system it's meet the specification. This is the verifications. It's verify whether the system is meet the specification. But formal verifications we can say is the act of approving or disapprove the correctness of the methods that use in this system. So there is some methods we should do verify is this or the design of the system. Is this design is meet the specification or not? So the formal verification is the act of approving or disapprove the correctness of the algorithm underlying a system. So we have some tools that can be used for formal specification or formal verifications. This tool like Uppaal's Visual States Spain, but we are in this course we are focusing only on Uppaal. So in Uppaal we will see how to design the model. So this is the first one. Once you design the model, you can validate your system. And then we will see how to verify this model. Verify this model by check some properties. Okay. One thing here is generating the code. Actually, in some tools, some modeling tools, we can generate the code from the system or from the model. One example of these tools is entity frameworks. If you use or if you hear about it, entity frameworks, it's tool for designing the model or also designing the classes also designing the interfaces. So, but if you generate one of them, for example, you generate the model, and then based on this model, you can generate the code. So you don't have to write code. You don't have to write, for example, the classes of the code of this system. So just based on the model, we can generate the code, and then we can generate the interfaces. Just we develop the model. Also, we can use another tool also for generate the test cases. So our formal methods, before we go to the implementations, we can generate, we can verify the design. We can model the design and then verify the design using the Uppaal. So here is the verification or the formal verifications. So we come also with something also we call it is model checking. So what's the model checking? Model checking is one of the formal methods. So we talk about the formal methods. So what's the model checking? Model checking is one of the verification or the formal verification techniques based on the model, based on modelings. Because some verification methods or formal verification methods is based on some pure mathematics, but here it's based on modelings. Also it's based on some mathematics. Some mathematics, we are not only using a model, but later when we want to check the some properties, we should to write it in mathematics. And this model checking actually, it's, as we say, is try to check all the state space, all the problem space. As we say, maybe the difference between testing and model checkings. In testing, maybe we just generate some representative test cases, but in model checking, we try to explore all the possibilities of certain properties. So we continue also model checking. In model checkings, also we say that we model the system. So based on the system description and the requirements, we use the model checking. Here we say it's Uppaal model checkings. We use the Uppaal model checking for verify some properties, and if these properties it's correct, satisfy and correct, so we can go to the next step, which is execute the code or develop the prototypes. But if not, so we should go back to designing or modify the model. As I mentioned also, it's not only Uppaal is tool for model checker, but there is another tool like Visual Spain, like Visual State and Spain and CBN, and all is as model as a model checking. So until now, where we are and what is the Uppaal? Actually, we talk about the verification in general, which is verify either the software meets the requirements or not, and then some of them is use some formal verifications, use some mathematics, use some that's why we call it is a formal, and then some of this formal verification is based on modeling, so they call it is model checkings, and one of these tool is Uppaal. So Uppaal is tool for formal verification, it's tool for model checking. So this is the Uppaal. So what's the Uppaal now? As we say, it's just is a tool for model checking, for formal verifications. We focus on the verifications. Even the tool can be used for validations, but in our topics, in our course, we focus about the verification. Of course, also modeling, because we should to model the system and then we verify some properties. So this is the Uppaal. As they define here, Uppaal is an integrated environment for modeling, simulations, and verification of the time of real-time system. One thing here, actually, after modeling the system, there is three parts in the Uppaal. Uppaal is, we will mention that later. It's modeling the system, describing the system. We describe the system as a model. We describe the system as a state machine. We describe the system as something we call it timed automata. Timed automata. It's quite different about state machine, but it's you both is modeling system. Uh, so simulations. The other part is simulations. You can see the the timing of the system. You can check the timing of the system. So this is the simulation. The third part is verifications. The verification actually, as we say, to check some properties. So where the software, the Uppaal, it's come. Actually, the software, the Uppaal is developing by two universities, and you can see the name of Uppaal. It's come from the name of these two universities. The first is Uppsala University, and the second is Aalborg University. So these two universities is joining together and developing this system. But before it's only the Uppsala University start developing this system, and the first it's named as TAP. So as I mentioned, Uppaal is system for modeling, validations, and verifications. So modeling, validation, and verifications. So modelings, we use some graphical modeling language. We use here something we call it automata. Automata, it's it's kind of graphical presentation of the system. So we model the system using this time automata, and then we can simulate, we can validate the system by checking some error, by checking either this system is meet the requirements or no. Also, and then later we can verify some properties. Verify some properties. So we can say that our tools can be used for modeling, for validation, for verifications. Even you can use this model or this system or this tool to model your own programs. We are not talking only about real-time system like robots and for example, it's self-car or driving car or something. No, even your software, your final year project, you can use Uppaal to verify this system and approve that the system is correct, or approve the correctness of the system.